Good afternoon, everyone. My name is Daria Liutova, and today I'm going to present our work, Multilingual Code Comment Translation, a case study on Chinese, English, and Russian. In my talk, I will focus on a specific but very practical task, translating Chinese comments in Python code into Russian and English, so that both the natural language content and the code context are preserved. Let me start with the motivation. Modern software development is almost always multilingual and multinational. We know from developer surveys that most engineers work in teams where multiple languages are used on a daily basis. And this is clearly reflected in the code base. Repositories mix English, Chinese, Russian, and many other languages. When comments are written in different languages, a few things happen. Understanding the code becomes harder. Code reviews takes longer, and onboarding new teammates is more painful sometimes. A developer may feel confident in Python, but struggle to read a comment, which is written in a language they don't speak. At the same time, general-purpose machine translation systems, the ones we can use for regular documentation or websites, are not designed with source code in mind. They often ignore code syntax, mishandle identifiers, or translate technical terms in strange ways. And it can be a serious problem, and their comments may happen not so useful. Our work addresses the gap for this scenario, where projects in Chinese, Russian, or English developers presented. Formally, the task we consider is the following. We take Chinese comment in Python source code and translate them into Russian and English. The key requirements is not just to produce fluent text, but to preserve code-specific terminology, keep the translation consistent with the surrounding code, and the special identifiers. Our contributions can be summarized in several points. We create specialized parallel corpus of Chinese comments from real-world Python projects with human translation into Russian and English, and with metadata on comment type and code context. We evaluate some multilingual natural machine translation models and large language models in both zero-shot and fine-tuned settings. We complement automatic metrics with an LLM-based expert evaluation of the best performing model, and we've focused on meaning preservation and terminology accuracy. And finally, we deploy the best model as an interactive tool on Hugging Face spaces. Now, why can't we simply take an off-the-shelf translation system and be done? The challenge is that code comments are not just plain text. They are hybrids. They contain natural language, but it also have a lot of programming constructs, variable names, type names, API calls, and so on. The translation must not break the code. We must not change identifiers, indentations, or special markers. And second, we must preserve the technical meaning of the comment, especially in the presence of domain-specific terminology. In our analysis, we distinguish between two main types of comments, single line and multi-line. Single line comments are short, often attached to a single statement. Multi-line comments behave more like compact documentation. We use one translation setup for both types, but we analyze how well models handle these structurally different cases. To evaluate and improve translation models, we need a realistic but focused dataset. Starting from Python projects with Chinese comments in data science and machine learning workflows, we constructed a trilingual corpus of code comments. It contains 1,258 manually annotated comment instances, which covers a range of coding styles, typical data processing tasks. Each entry of the corpus includes file path, path to the Python file, the fragment of source code containing the comment type, single line or multi-line, the original Chinese comment, and human translation into Russian and English. We keep the original formatting and do not touch the code itself. Only minor white spaces normalization was applied. So the comment stays aligned with executable Python code. For experiments, we stratify by comment types and split the corpus into training, validation, and test instances. Before training any model, we must look at basic statistics. If we consider all comment types together, Chinese comments are the most compact, on average 33 and 7 characters, while Russian and English translation are much longer. When we separate single line and multi-line comments, the difference becomes even clearer. Single line comments are very short, usually below 160 characters, and act like labels. Multi-line comments are roughly an order of magnitude longer and behave like documentation blocks. This matters for translation because the same model must handle both very short, fragmentary text and longer discourse-like explanation. Another interesting property of our corpus is the amount of English embedded in the comments themselves. Latin characters account for a substantial portion of Chinese and Russian comments, especially when we look only at comments that contain such fragments. On this slide, you can see two single lines comments from our corpus. The first example, in both English and Russian translations, we keep the token data frame exactly the same because it is a class named from the pandas library and must not be translated. In the second comment, we have another typical technical token nan, which also appears identically in Chinese, English, and Russian. This example illustrates two important properties of our data. Single-line comments are very short. They almost always mix natural language with code-specific tokens, and the translation must preserve this. So even for single-line comments, translation is not just about language. It is about respecting the structure of the code. Multi-line comments are practically affected. More than half of them contain Latin fragments in both Chinese and Russian, and English, of course. Examples include type names like int, float, data structures such as data frame, file formats like JSON, library identifiers such as sequential forward selection, repeated key fold, and so on. And for this type of comment, the task becomes more challenging. The model has to produce a fluent, long explanation, but still respecting the formatting and all code-related identifiers. This is much closer to real documentation than to a simple one line labeled in the code. Let me now briefly explain the models and the evaluation setup. In our experiments, we use several multilingual machine translation systems and two large language models. All of them support Chinese-Russian and Chinese-English directions. We cover both classic encoder-decoder machine translation models and more general LLMs. For each system, we tested in two modes. First, zero-shot mode, when we simply ask the model to translate the comments without any additional training. Second, fine-tuned mode, when the same model is adapted to our corpus of code comments. To compare the outputs, we used three standard metrics, BLEU, burst score, and comet. All of them are reported on a scale from 0 to 1, and the highest beta. but they look in the quality in slightly different ways. Blue is a classic n-gram overlap matrix. It measures how many short word sequences in the translation match those in the human reference. It is quite sensitive to exact phrasing and word order. BERT score uses contextual embeddings from a pre-trained language model and compare the hypothesis and the reference in the semantic space. It's closer to measuring meaning similarity. And it's less strict to word orders and exact words. Comet is a learned quality estimator. It takes the source, the reference, and the translation, and it predicts a quality score that correlates with human judgment. You can think of it as a small model trained to behave like an automatic human rater. By looking at all three metrics together, we can get a more robust picture. Blue tells us about surface overlap, BERT score about semantic similarity, and Comet about overall adequacy of the text, of the translation. What happens if we simply apply these models out of the box? In the Chinese-English direction, BART performs best overall. In the Chinese-Russian direction, M2M comes out on top. However, we also observe semantic problems. For NLLB and Chinese-Russian directions, we see empty outputs or outputs in the wrong language. It makes this translation unreliable, and it needed adaptation. This behavior is most likely related to the much weaker support for the Chinese or Chinese-Russian pair, we think, because there are maybe there was no such data in the pre-training of NLLB. T5 and the BART sometimes leave parts of the commented Chinese, and translation is incomplete. Overall, zero-shot models show a clear quality gap between Chinese English and Chinese Russian, and it depends on data, I think. After fine-tuning on our very small, I think, corpus, the picture changes. All four multilingual models improve across all metrics about translation in both translation directions. Sorry. The best results are achieved by M2M, both for Chinese Russian and Chinese English. We see strong gains compared to the zero-shot baseline. Importantly, fine-tuning also stabilized the behavior of the models. The catastrophic empty or wrong language outputs from NLLB disappeared. The tendency to leave Chinese segments untranslated is greatly reduced. In other words, with a relatively small but highly specialized corpus, we can significantly improve and regularize translation quality for very specific tasks. Automatic metrics are very useful, but they don't always capture what matters to developers. To get a more nuanced view, we use DeepSeek as an LLM-based expert evaluator through API. For each translation, DeepSeek reviews the source comment, the reference human translation, and the model output. It provides a score for meaning preservation, a score for terminology accuracy, both on a scale from 1 to 5, and a binary decision whether the translation is acceptable. For the best model M2M, after fine-tuning, we find that in Chinese English, most translations are rated highly on meaning, and about 2/3 are considered acceptable overall. In Chinese Russian, semantic adequacy is still good, but terminology consistency is more problematic, so just over half of the translations are judged acceptable. This confirms what we see in practice. Modern models are already good in capturing the overall meaning, but they maintain stable and correct technical terminology, especially in Chinese-Russian pair, and this remains challenging. We make the research practically useful. We turned the best performing model into interactive tool. We deploy the fine-tuned M2M model on Hugging Face spaces as a web interface. A developer can upload a file with Python code containing Chinese comments and obtain the same file with the comment translated in the Russian, while the code itself stays untouched. This can support multilingual teams, we think. Of course, there are limitations, a lot of limitations, I think. First, the corpus is relatively small. It focuses on a specific setting, only Python projects with Chinese comments, only in data science projects. We do not yet cover other programming languages or other combinations like Chinese Spanish maybe, or Chinese Arabic. Second, we use multiple automatic metrics and LLM-based evaluator, but we still lack a large-scale human study with professional developers writing the impact of the translation quality on their actual work. In terms of future work, we see several directions: extending the corpus to more programming languages and domains, improving explicit handling of terminology, perhaps with dedicated lexicons or constraints, and designing evaluation protocols that better reflect real developable needs. We're also interested in releasing a de-identified or partially synthetic maybe version of the corpus that could be safely shared with the community for further research. To conclude, we argue that code comment translation is specific machine translation problem, which preserving identifiers and technical details as important as fluent language. We introduced our corpus. We showed that zero-shot multilingual models provide a decent starting point, but they suffer from systematic errors, especially on Chinese and Russian. We demonstrated that fine-tuning on this small but task-specific corpus significantly improves translation quality. And finally, we deployed our best model as a Hugging Face space. Thank you very much for your attention. I'll be happy to answer your questions.
Sure, I have a question. Well, first of all, thank you for the presentation. It sounds interesting. And I'm, as a Java developer, thinking about whether this is applicable to Java, but you already mentioned that you think about working into this direction. That's right?
Yes, I think it will be a very good to take other languages, take other domains, languages. I mean Java maybe or C#. I don't know, something that developers need to translate.
But is it going to be difficult in some sense, or you just automatically switch to a different language and nothing changes? What's your prediction?
As for me, I think that the Python is more challenging because it's very close to natural language in some points. Because you need to divide these terms which in code and terms which in single line on multi-line comments. Maybe Java will be simpler, but I don't know.
And did you try to use comments with markdown formatting inside or HTML inside?
No.
So it's only plain text.
Yes, plain text, but maybe it will be our next step, I think.
Okay. And you didn't say anything, or maybe I missed, about related work. Is something done by somebody else in the same direction? Did you try to compare your solution to existing products?
Yes, of course. I have this part in my in our article but I thought that it would be not the main part of presentation.
Well, you can just say verbally, just say a few words. Do these studies
Yes,
exist?
yes,
What's the results there?
yes. There are some studies exists. There are good results, but they didn't compare with single multi-lines. They didn't compare zero shot, few shot modes. They're different from our from ours
Mhm.
research.
Mhm. Because the numbers that you demonstrated, they look promising, but I question myself, maybe somebody else already have better numbers or better methods to do the same.
I didn't compare these numbers.
You don't know.
I don't know. Yes.
Mhm. Because it seems to me that maybe instead of just throwing the full text to the model and asking the model to do the translation, maybe you can first extract these terms from the text or maybe highlight them somehow, and that will make it easier for the model to spot them in the text. But you don't do that. You just pre-tune, you just fine-tune the model, you train the model with your data set, and that gives you a better performance.
Yes, yes.
Right?
The big problem is to have more data. The data as for other tasks, very difficult to collect, very difficult to annotate. That's why we have only this mode: Chinese, Russian, and English, and data science on
Mhm.
Python.
And also, you didn't mention where did you get the data set? Is it coming from open source projects or commercial projects?
It is coming from open source projects,
Mhm.
and my co-author Wang Yu collected them.
Mhm.
But on my part was training models and writing an article.
Ah, got it. Okay. And by this training the model, how much resources did it take? How expensive was this task?
It
Because we
wasn't
all know, no?
it wasn't expensive for transformers at all.
Mhm.
Uh, it is not very fast, but it's okay.
And also, you told that you said that you did use DeepSeek as a verifier on the final step, but again, my question would be, what if we replace these models which you used by more powerful models, like let's say ChatGPT or the DeepSeek by itself? Maybe they would generate the right answers without any fine tuning, without any training.
I think they'll be better and show better performance, of course.
Mhm. But you didn't
But it's
check
not.
that.
But it's not open source. It's not
Right.
local.
Yeah.
We wanted to make a local model which can work on your computer.
Mhm. So you're planning probably to make this integratable into the IDE, for example, for the developer, right? So you are planning to integrate your software into the IDE of a programmer.
Maybe yes. It
Yes.
can be a part of some pipeline of programming, developing, or something like this.
Mhm. So I just find the place in my source code. I just highlight it, click translate, and it just converts from Chinese to.
Don't need to highlight. You can take your all Python code with
Uh
comments, and the model can search these lines.
huh. Okay. It can search the lines and translate automatically.
You can see our Hugging Face spaces.
Hmm.
You need to download your Python file, and then you take the same file but with translation only in code in comments.
Hmm. Nice. That's really
But I
interesting.
think we need to improve this tool. We need to add English language, of course, because it's only Chinese to Russian,
Mhm.
and maybe improve our models a little.
And did you think about the opposite translation from English to Chinese or from Russian to Chinese?
Yes, I thought about it. But I can't validate it at all, I think. But only with models, LLMs, I'm a little bit scared of translation into Chinese.
Because you personally cannot understand whether it's okay or not. So DeepSeek for you was not the ultimate judge. You personally was the judge. You looked at it.
Exactly. Yes, I looked through all the texts, of course, because it was interesting for me. In zero shot, before fine tuning, it was a parts of Chinese text. It was some strange texts, and I was very surprised that NLP can't translate this without fine tuning. Because it's very good model with 2,000 languages, but the direction Chinese Russian was maybe not so good.
And the key problem was the inability to spot these terms, the technical terms in the text. Am I right?
It wasn't so difficult because the model see the code unchanged, and the model understand that it that it doesn't need to change something in the code. I think it wasn't a problem.
So the problem was in general that the model did not understand the meaning of the
Yes.
text.
Yes.
Interesting. And just fine tuning with your data set was the help.
Yes.
Was the improvement.
And the metrics grow very.
And your data set just about 1,000 examples.
1,000.
It's 1,100 or something, 200.
Yeah.
It's really small, right?
Small.
For training. So maybe the quality of it was good because it was manually crafted by hand.
As a Russian, I saw some mistakes in Russian texts. I saw, but it doesn't matter on the whole.
Okay. Okay, thank you very much. Thanks for being with us. See you next year with your next study.
Okay. Thank you.
Okay, bye-bye.